welcome you back to the lecture series of Transportation Engineering 2 course material. In today's lecture, we will be discussing rail fastenings. So far what we have discussed is the different types of components which are used in the construction of any railway track. In these components, we have already seen about or discussed rail, sleepers and ballast. In today's lecture, we will be looking at the various fastenings which are used to fix the rails with the sleepers. In the case of sleepers, we have already seen that there are different types of sleepers available to us, and therefore, there are different fastenings which are available which can be used to connect rails with all those type of sleepers. So, in the today's lecture, we will be looking at track fittings, rail to rail fittings, rail to sleeper fittings. So, we will be starting with the different types of fastenings, and these different type of fastenings, the first one is the rail to rail joining. As we have seen in the case of any track, there are different sections which are composed of the rails which are manufactured in a specified length. Therefore, there is going to be a connectivity between these rail to rails. And then the another category is the rail to wooden sleeper fittings. We have seen that the sleepers are of different types. The old type of sleepers which have been in use were wooden sleepers. So, therefore, the fittings which are required to connect rails with the wooden sleepers will be seen. Then there are rail to steel through sleepers. This is another category of sleepers which are already being discussed. Then there is a connectivity of rail to CI sleepers. So, these are all metal sleepers which are being connected to the rails. Then there are elastic fastenings. So, in these case of fastenings, we have conventional fastenings and elastic fastenings. So, there will be two categories in which we will be discussing these. Basically, all the fastenings which we will be discussing prior to elastic fastenings will fall in the category of conventional fastenings, and they will be related to rail joinings or rail to wooden sleepers joinings, or rail to steel trough sleeper joinings, or rail to CI sleeper joining. In the case of rail to rail joining, we will be looking at fish plates, bolts and nuts. These are the fastenings or the fixtures which are used to connect the one rail with the another rail. In the case of rail to wooden sleeper fittings, we will be discussing dog spike, fang bolts or screw spikes and bearing plates. We have lot more other fittings also, but these are some of the important fittings which we will be discussing. Then in the case of rail to steel trough sleepers, we will be discussing the loose jaws, keys and liners. We have already seen in the previous lecture where we have discussed about sleepers. In the case of steel trough sleepers or CI or pot sleepers, there are different categories where loose jaw category or the lug up category are there. So, therefore, in all those categories, so as to fix rail with the sleeper, we require jaws as well as keys. So, we will discuss these type of fastenings in today's lecture. Then in the case of CI sleepers, the another thing which is being used so as to connect the tie bar with the pot type of sleeper was cotters. So, the tie bars and cotters will be seen. And then in the case of elastic fastenings, there are large number of elastic fastenings available to us nowadays. So, we will be looking at the elastic fastenings like elastic or pandural clip, the IRN 202 clip. This is the Indian Railway number clip which is being produced by the RDSO and the Railway Ministry, the rubber pads, HM fastenings, MCI insert and nylon liners. So, in this case, we will be starting with the very first category, that is rail to rail fastenings. In the case of rail to rail fastenings, the most important and the primary fastening which is being used is fish plate. Now, this fish plate is designated as IRS T-1/57. This is the designation number of fish plates in the overall technical glossary of Indian Railways. So, as soon as anybody related to the railways is being given this number, the person can understand that we are talking about the fish plates. So, there is no need of giving the other specifications of that fish plate as soon as the number has been specified. Now, in these fish plates, they require certain strength. We have seen that when the two rail sections have been jointed together and fish plates have the function to perform to keep those rails jointed with each other at the same time to maintain their level also. And they also try to impart some more stability and strength to the joint, which is otherwise is a point of a weakness. So, in that sense it should have some amount of strength available to it. So, here we are talking about the strength. This is UTS, which is ultimate tensile strength. At a minimum level it should be 58 to 67 kg per mm square. Then there is a tendency of deformation under the loads. So, there is a tendency of deformation under the thermal stresses. In that case the elongation may be there, and the minimum elongation required in this case is 20%. The sectional area of the fish plates should be equal to the sectional area of the rail section. In the case of the rail section, the overall sectional area will be the composition of the rail head, web and the foot. So, on the basis of that total sectional area, we have to find out the area of the fish plate and design it accordingly. And in the overall condition, the strength of the fish plates is around 55% of the strength of the rail section. And this is the type of the fish plates which are generally in use. Here we see that this is a fish plate which is a sort of a channel shape like this, a C is there, whereas in this case it is having a shape of curvilinear condition, and it can be termed as a sort of a dumbbell shaped. Both the type of fish plates are in use on specific locations as well as for a different type of rail sections, which are again available to us and which have already been discussed when we started with the rails. Now, this is another typical view where the connectivity of one rail section with another rail section has been shown here, and this is the joint. So, this is one rail section on this side, another rail section on this side, and here we can see the fish plates being provided. So, this is a channel shape fish plate which is provided on this side, and there are two bolts which are provided on either of the side of this joint. So, in this composition we have two plates, because one plate will be provided on the other side, that is the inner side of the gauge face of the rail, and the one fish plate is provided on the outer side of the rail. So, at one particular joint there will be two fish plates and 4 bolts and 4 nuts. So, this is the total assembly which will be there as far as the requirement of material is concerned for any one joint. Then this is another view of the rail to rail joining. In this case, this is a sectional view of this one. We have this rail section being placed like this, and on this rail section then we are placing the fish plates. Here we can see that this is a fish plate which is abutting at this location like this. So, the shape of the fish plate is being provided in this form, and then at this level also it has to be provided in a way so that it rests on the foot of the rail section, and this is another side of the fish plate. These are the two fish plates which have been used, and they have been jointed by a same bolt. So, this is a bolt and this is a nut. So, this bolt is passing from one fish plate going through the rail section and then coming to the other side and is being fastened with the nut. So, in this case, if there is any looseness at this level, whether it is because of the size of the hole or because it is these nuts or bolts have not been fastened in a tight condition, then there will be a relative movement of the rail sections as well as soon as there is a load which is passing from the top of it. So, that is why it is important to have the tight condition of all the 4 bolts which are provided on these fish plates. And we can see that this is a 44.7 kg rail which is being shown here along with its dimensions. In this case, this is 1:4 slope at which this fish plate is being cut in this size, so that it fits in with this rail section. Now, as soon as it gets fit in with this rail section here, we can assume that the whatever load is coming from the top at this location will get distributed not only through the web section of this rail like this to the foot of the rail section, but will also get transferred through this section as well as through this section and will come back to the bottom. In that sense, if we assume that there is no load which is being transferred through this section, that is the web of the rail, then 50% of the load will get transferred through this one and 50% of the load will get transferred to this one. And that is the reason why this rail is fish plates, they are supposed to have 55% of the strength of the rail section. So, when we are using 2 fish plates, it is more than 100% strength of the rail sections, and that is how it survives without breaking. Now, another type of connectivity between the rail to rail section is the combination fish plate. The combination fish plates joins 2 different rail sections. There are certain conditions or locations where the 2 rail sections which have been jointed together are not of same size or sectional area. So, in that case we have to use combination fish plates. In the case of combination fish plates, there will be additional thickening of the joint, the elimination of expansion gap will be there, and the fish plates marked as right in or right out. This is instead of R is out, and left in and out depending upon direction from lighter rail to the heavier rail. It means when we are using 2 different rail sections, obviously there is going to be a difference in the sectional area as well as sectional weight of those rail sections. So, in that sense, one rail section which is having a lesser weight will be termed as a lighter rail, and another rail section will be termed as heavier rail. Now, based on the location of the lighter rail with respect to the heavier rail, the fish plates are designated as right in or right out, or left in or left out. Now, in this case we can see the diagram that this is of combination fish plate, where this is a bigger section, this is the rail section which is provided by a dotted line like this, and this is another section which is a lighter rail section, and both these sections have been jointed together. Now, in the normal conditions where the one rail section is been jointed with the another rail section, a gap is allowed between those 2 rail sections, but in this case there is no gap being provided. So, it means they are butting each other. Now, in this case there is one fish plate which is used here, and this is another fish plate which has been used here. So, when we are using in this form, then this fish plate will go on the other side of the rail section, and this fish plate is coming on the other side of the rail section, and that is how there is an overlapping in this much area. So, these lines, this is the end of one fish plate, and this line shows the end of the another fish plate which is coming from this direction. So, in that sense, when there is overlapping of the area, what we found is that there is additional thickening at the joint section like this. So, this is additional thickness at this level, additional thickness at this level, and this is the normal thickness of a fish plate on this side and normal thickness of a fish plate on the other side. Now, when we are having this lighter rail and this is a heavier rail, so the direction in which we will be looking at these fish plates is in this direction. So, this is the arrow which is showing the direction. So, when you look on these fish plates in this direction, we have this as right hand side and this as left hand side. So, this is outer side. So, this is right outer fish plate, and this is right inner fish plate. Similarly, this is left inner fish plate and left outer fish plates. Likewise, and these needs to be designated, and that is how they are also placed and jointed together. So, again we are using 4 bolts. One bolt is going in this fish plate. This is, there is no overlapping area here. Similarly, there is no overlapping area here, and then 2 bolts will be coming through this additional thickness area, and this is how it is being connected. Now, we come to the another category of connectivities, that is between rails and sleepers. In the case of rails and sleepers, the previous type of sleepers which have been in use are wooden sleepers, and still there are some sections where the wooden sleepers are going in use. So, we have to look at those fastenings which have been used so as to connect the wooden sleepers and the rails. And this connectivity, the first one which is of importance is a spike. There are different type of spikes available. So, under those spikes there is dog spike. Dog spike is this is a diagram which tries to give the dimensions as well as the shape of the dog spike. Here what we found is that the shape of this one is something like this. So, this is just similar to the face of a dog, whereas this is the back side of this one. If you look it on this section from this direction, then you will found that it looks like this way. So, looking at this section only, the name has been given as a dog spike. So, it has this conical surface at the bottom through which it will be inserted into the wooden surface. So, it is hammered from the top and then it goes, because of this conical surface, initially it will take a penetration condition and then through that penetration condition it will be going inside into the wooden sleeper. So, this is how the dog spikes work, and this is another view of the dog spike, where again this is going like this and we have a little more conical surface in this one, whereas in this one it is a truncated conical surface. So, that it is a little blunt at the bottom. Then under the spikes condition, the another type of spike is the round spike. This round spike is mostly used with anti-creep bearing plate. Now, these anti-creep condition we have seen when we have talked about the creep in rails, where the rails move in the longitudinal direction. So, these are the round spikes which are used with the anti-creep bearing plates so as to keep those rail sections in place. This is the diagram of a round spike. Here what we found is that this remains similar to the dog spike as we have seen in the previous diagram. It also has a truncated cone at the bottom, but at the top it is being provided with a cap, and this is how this is stuck at the level. When it is inserted into a hole, then it is working like a bolt. So, the top of the bolt is like this only. So, it will be abutting to the surface so that it remains in place. The hole will be inserted into the bearing plate as well as it will be inserted into the bottom of the or foot of the rail section through which it will pass and fasten the rail with the wooden sleepers. The another category in the case of spikes is fang bolts. These fang bolts are mostly used for the slide chairs or the sleeper connectivities under switches. Now, these slide chairs or switches, they are the terminologies or the devices which are mostly used at the places where the direction change of a track is to be provided, and those locations are termed as points and crossings. When the points and crossings will be discussed, we will be taking up the switches there, and the slide chairs are the equipment which allows to rail to move in a certain direction, so that the connectivity between one track to the other track can be provided. So, in these cases where the slide chairs or switches are provided, the fang bolts are used. This diagram shows the different types of the fang bolts which are available. We can see the shape of these fang bolts. Most of the fang bolts, they are having a almost similar sort of design. Only thing with the changes are coming at the top. This is one thing. In some of the cases, the pitches which are provided, they are of a different value. Here they are more of similar condition, here they are projected one, and like these are the differences in all these. Then there is another spike which is termed as screw spike. Now, these screw spike, this is also available in two types. One is a plate screw, another one is a rail screw. Most of the time these are used in high speed trunk routes. What happens in the previous type of the spikes which we have seen so far is that with the jerks or with the loads which are being transmitted through them, slowly and slowly they start getting loosened out, and in that sense, if we are using those type of spikes on the high speed trunk routes, then the periodical maintenance requirement increases. So, therefore, instead of those type of spikes, we use screw spikes, and because of the screwing nature, they have a tendency to remain in position, and they are not getting loosened out again and again. In the case of this plate screw, we are using a plate along with the spike or the screw. That is why the name plate screw is being given, whereas the rail screw is the spike or the screw which is directly fitted with the rail section just through that its hole. In this case, these are again of a similar sort of condition, like as we have seen in the case of the bolts. This is the one diagram where the screw spike has been shown. Here, instead of the bolts, the only difference which comes is that all these screws, they are coming up to the top of this one, so that when it is inserted inside, then through this hole it will get connected to the topmost surface of the rail section, and still it will maintain tightly the fitting of that rail section with the wooden sleeper. So, there will not be any loosening effect because of this much amount of screwing being provided. Then the another category of fastenings which are used in the case of the wooden sleepers are bearing plates. Bearing plates are mostly provided because the whatever rails which we have been using, like the dumbbell shaped rails or double head rails or bull headed rails or flat footed rails, as soon as the load comes from the top, there is a tendency of the foot to go inside the wooden surface. So, it will start penetrating it and there will be a wearing of the surface of that wooden sleeper at the location where the rail is being placed. So, as to remove or eliminate this type of a condition, the bearing plates are provided. So, these bearing plates are available in different forms. They are the mild steel canted bearing plate. Canted bearing plate is a plate where 1 in 20 slope is provided, because the rails have to be placed at this slope, so that the coning of the wheel which is being done, there is no problem because of the coning of the wheel and the rail sections being provided. And mostly these MS canted bearing plates, they are provided on joints or on the curves. Then there are another category, that is flat mild steel bearing plate. In the case of flat mild steel bearing plate, these are provided for points and crossings where the turning of the track is allowed, and they are provided with dog spike. Then there is cast iron anti creep bearing plate, is also termed as ACB plate, and this is provided on all those locations where the creep is a possibility. Again, in these cases, the 1 in 20 slope is provided at the bottom, so as to seat the rail section, and round spikes are used in this case instead of the dog spikes. Then there are some special cast iron BP plates which are used for bull headed rails, and in this case of bull headed rails, we have seen the head of the rail is bigger as compared to the foot of the rail, and they are used with spring keys. So, we have different assemblies available, and we have to use in combination of those assemblies wherever they have to be used specifically. Then this is a diagram where the canted plate is being shown. We can see that there is a slope at this level. Here there is more thickness and here there is a lesser thickness. So, therefore, the cant is being provided. This cant is 1 in 20, and as soon as this 1 in 20 cant is provided, the wheels are also having the cant of 1 in 20. So, there by using this way, we will be having a total connectivity at the topmost surface of this rail head section with the wheels which are moving on those rail sections. And here we can see the dog spike also very clearly. This is a dog spike which is being provided, and this is getting inserted through this bearing plate, and then finally here at this level there is a sleeper. So, it goes into the sleeper like this. Similarly, on this side it is going into the through this bearing plate at this level into the sleeper like this. So, this is how it is creating a pressure so as to keep this rail section in its position. So, we in this diagram we can see the dog spike as well as the bearing plate. This is another type of bearing plate along provided with the chair. On this case, what we can see is this is the bottommost part, and this is specifically being used for the bull headed or double headed rail sections. You can see that there is a difference between this rail section and this rail section. Here the rail section is having a flat foot like this, whereas in this section we are having both the head as well as the foot are of similar nature. So, in this section what we have to do is that we have to use a spring key. This is a spring key. So, this spring is provided like this, and because of its springing action, it will maintain the rail section in its location. So, this is because of this thing that this rail section is just sitting at this one. This assembly is termed as chair. So, this is cast iron chair, and here there is a hole through which the spike has to be inserted. So, this is a spike hole. We can have this rounded spikes at this level, we can say that this is the thickness as being shown here. So, this is the rounded part of the spike. So, this is inserted inside like this, similarly it is being inserted inside like this. So, these are the assemblies which are available in the case of rail to wooden sleepers connectivity. Then in this case this is another similar sort of condition, but with different type of connectivities. Here what we can see is that instead of a spring, this is one say the angle which is coming out of the bearing plate section, and then at this level their connectivity is provided using the bolts and the nuts. And in this case what happens is, this is a condition for points and crossings where this rail section has a tendency to move. So, this rail section can move to this side or it can move to this side. So, this is the distance which is shown here. By this distance this rail section can move this way or this way. Now, when this rail section moves this way or it moves to this way, so depending on whether there is another gauge face of a rail section being provided on this side, it will get connected to the another rail section. So, as soon as this rail section get connected to the another rail section, it allows the change of direction of any train. So, this is used at those locations where the change in direction of a train is to be provided. So, that is why it is termed as chair and slide chair condition. So, there is a chair being provided here, and due to this arrangement it has a tendency to slide. So, that is why it is a chair and a slide chair arrangement. Now, we come to another category of connectivities. This category of connectivity is between rail and the steel sleepers. Here the first thing which is to be used is a loose jaw. Loose jaw is used to, there is a spring steel loose jaw with keys. There is no problem of damaging with these type of loose jaws, and there is cracking or deforming is also not there, and they are easily replicable. These loose jaws are provided with the keys, as this is the diagram of a loose jaw. This will go below the rail surface, and at this level it is trying to provide the lateral stability so that the rail section is not falling away. So, this is the type of the loose jaw provided. And along with these loose jaws, the keys are used. There are different types of keys. There are some keys which are one-way keys, and then some keys which are two-way keys. In the case of two-way key, this is taper at an angle of 1 in 32, and they are generally used with the steel trough sleepers or the pot sleepers or the CST9 sleepers. Now, in the case when we have seen the diagrams of trough sleepers or pot sleepers on CST9 sleepers, we have seen that there was a location where the key has been inserted. So, this is the type of the key. This is a longitudinal section, a tapered longitudinal section which is provided a value at 1 in 32, and it is square or rectangular at both the ends. Then there is another thing which is at times used is a rubber coated or epoxy coated fish plate. This rubber coated or epoxy coated fish plate is used on insulated joints, but because these coatings get damaged quite early. Then in the similar category of rail steel sleepers, there is another type of a liner which tries to again fasten or keep the connectivity of rail along with the steel sleepers in position, and this is known as Motasingh liner. Motasingh has been an employee of Indian Railways, and on the basis of his experience he devised one liner, and with his name it is being termed as Motasingh liner. This is used for loose jaws so as to overcome the problem of elongated holes. What happens in this case is that once the loose jaws are provided and the holes through which some other fixtures have been inserted, slowly and slowly those holes start becoming elongated or bigger, and as soon as this happens, then there is a loosening effect which comes into the overall fixture. So as to remove that one, Motasingh devised the one liner, and this is the shape of that liner. This is another diagram which shows the same thing from the other direction. This is one design which is being specified and standardized on Indian Railways and is known in the name of Motasing. Now, another fastening which is used in the case of connectivity of rail with the CI sleeper is cotters. Cotters are used so as to fix the tie bars with the CI sleepers, and there are different type of cotters. We have the central split cotter, we have the side split cotter. Central split cotter is being split at the central location, and whereas the side split is being cut at the side, so as to insert into the tie bar and fix it or with the tie bar with the CI sleeper. And there is another type of cotter which is solid and split cotter, and then there is a band plate cotter. Then there is a tie bar, there is a mild steel tie bar which is used so as to connect the two sleepers which are provided below the two rail sections used in the same gauge. These holds the two plates of CST9 sleeper together, and its dimensions are length 2720 mm and section is 50 mm by 13 mm. Now, we come to the elastic fastenings. So far, whatever fastenings we have seen, they are termed as the conventional fastenings, and these conventional fastenings are used in general with the wooden sleepers, with the, as we have seen, with the metal sleepers. But elastic fastenings are the fastenings which can be used not only with all these wooden sleepers or the metal sleepers, but they are also used with the concrete sleepers. In these elastic fastenings, there are certain requirements. We will look at those requirements now. The very first thing is that they should have adequate toe load. The toe load is a position where it is transferring the load from the top to the bottom surface. So, if it is not having a capacity to take up the load, then it is going to break down or will crack. So, in that case it will not be fulfilling the function for which they have been provided. Therefore, all these elastic fastenings, most of the time they are divided and designed and designated with certain toe load. Then they should have sufficient elasticity to absorb shocks and vibrations. As from the word itself we understand that these are elastic fastenings, means they have the tendency that they should be able to absorb shocks and vibrations, and still they should come back to their normal orientation in which they have been provided. They should hold the gauge and they should maintain the track. That is another thing with respect to the fastenings. Not only with respect to these fastenings, whatever fastenings needs to be used, obviously this is a one requirement which should be fulfilled, that those fastenings should hold the gauge as well as maintain the track. They should resist lateral forces, whatever lateral forces are coming, because there are different type of forces, as we have seen when we discuss resistances and we discuss the stresses. In that sense, these elastic fastenings should be able to take up all the type of forces and especially the lateral forces. They should be fit and forget type, means the maintenance requirements should be as less as possible. Once you have fitted in, then we should be able to forget that we have fitted something. They should be reusable, they should be cheap and should have long life. Then the another thing is that they should be universal type and should be sabotage free. That means the person should not be able to take it out as and when they feel it doing so, especially in the case of those tracks which are passing through the remote area where there is no safety provisions being taken up or cannot be taken up. So, they should get fit into the overall system in such a way that it is not easy to take them out for anybody who is not a skilled labor, is not having the devices so as to take it out in that form for maintenance purposes. Now, we start with the different types of elastic fastenings. The first type of elastic fastening which we are discussing is the pandroll or elastic clip, which is having a different numbers, and here we are discussing the PR401 clip. This is Pandrol 401 clip. This clip is a fit and forget type, which is one of the requirements of elastic fastenings. So, once we have fitted and then for a long period of time there is no requirement of doing anything to this type of Pandrol clip. The toe load is being designated as 710 kg, and at this toe load it has a nominal deflection of 11.4 mm. So, whatever load is coming from the top on these fastenings, obviously some deflection may take place because of the loading, and this is what is the value being defined for the amount of load it can take up. They are universal in nature, means they can be used at any location with any type of connectivity. So, that is why they are universal. They uses two more fixtures along with it. One is the base plate, another is CI insert. The base plate we have already discussed. The base plate is a similar type of a plate as we have discussed regarding the bearing plate. Only difference in this case is that it is a rectangular plate with the uniform thickness being provided, or at times these are provided with the grooves. We will be looking at this type of fixture further. Similarly, the CI insert, the cast iron inserts are there, which are used so as to connect these clips to the sleepers at the bottom. So, through base plate using CI insert, these will be fitted in. In these cases, because of this higher value of the toe load and the deflections, if it is there, and the inserts and everything, what happens is that in the later stages, if there is any problem or there is a requirement of maintaining a gauge or adjusting it, then it becomes a little difficult. First of all, we have to take out the clip, and then only that gauge adjustment can be done easily. The point contact causes indentation to the rail foot. This is another problem, or you can say a sort of a disadvantage in the case of a pandural clip. Here, because of the shape of the pandural clip, it happens to be touching the rail section at one or two locations, and wherever it is touching the rail section at the rail foot, the load is going to be transferred to that point only, and due to this reason there are all chances of getting the rail section indented at this location. So, this is one problem associated with this one, and at times this point where the indentation has happened may become the point of wearing of the surface. And another problem associated with the pandural clips is that they are theft prone. The people can take them out very easily, because only the CI inserts have to be taken out, and as soon as the inserts have been taken out, then we can easily take out the pandural clips. This is one photograph where the pandural clip has been shown, and this is another one. Here we can easily see that the shape of the thing which is provided at the bottom through which this clip is moving is like this, and there is a plate being provided here, and this section is coming and putting the toe load of 700 and something kgs at this position here. So, this is because of this shape, it is in a position to put up this much pressure at this location, and that is how it tries to maintain this rail section into position. Here you can see the another diagram, another this photograph where the clearly this rail section is being shown. Here there is a sleeper being provided, and through this sleeper we have used this clip. So, this is the location at which this is putting the pressure, and the pressure is so heavy that this rail section cannot move from its location. So, this pressure is to be created while fixing these pandural clips in this location, and this pandural clip at this location is going inside this section like this way. This is going inside here in this form, and if you can take out this one, then everything is out. So, therefore, that is why it is a theft prone condition in the pandural clips. In this one, what we are seeing is a connectivity of the rail section where the base plate is also being used. Now, when we are using a base plate, then we can see that there are two pandural clips which have been used here. One pandural clip is trying to fix the rail section on the base plate, and that is why this is how it is being provided here, and this is one pandural clip and the load is being transferred at this location. That is how it remains in a fixed condition. And then at this location there is an insulator which is being used at this location, and then the load is being transferred at this one, and this is the connectivity which is provided at the sleeper, which is located at the bottommost here. So, this connectivity is here. If you take out this connectivity, this is the only thing which is connecting the clip with the sleeper and with the base plate or the rail section. Then there is another clip which is IRN202 clip. This IRN202 clip is devised by Indian Railways, and there are different types of the clips. This clip is being given a name as 202 clip. This is mostly used for 2 block RCC sleepers. In this case, as we can see, the tow load has been increased. It has been made 1000 kg instead of 700 some kgs for the pandural clip, and there the deflection was of the category of around 11 mm. Here the deflection is 18.5 mm. So, on this loading condition the higher deflection is being permitted in this case. The creep resistance is 50% of the tow load. So, a heavy resistance is being offered in this case to the creep, and this is around 500 kgs. So, as to connect this IRN clip 202, we require bolts and clamps, and using these bolts and clamps then it can be kept in place. The removal of the rail is easy in this condition, whereas in the case of the pandural clip conditions it is not that easy. And but the problem in this one is that they are not fit and forget type, whereas the pandural clips were fit and forget type. So, there are some positive and some negative aspects associated here when we use IRN clip or when we use pandural clip, and they are costlier because of the total section of the IRN clip. The section of IRN clip is such that it is almost twice of the section of the pandural clip. So, instead of at one point where it is touching, the pandural clip is touching, this IRN clip tries to touch at 2 locations, and that is why this is heavier, and there is also a problem of corrosion in the case of IRN 202 clip. Then there is another clip which is elastic rail clip MK3. This is used with the rubber pads. These rubber pads are used as a 2 liners of 6 mm thickness with 60 kg rail sections, and 1 liner each of 16 mm thickness on non gauge side and 10 mm thickness on the gauge side with 52 kg rail section. So, what we see is that depending on the type of the rail section we are using, we have different types of the liners, or the number of liners may also change in those cases. And in this case the tow load is comparable to the tow load of the IRN 202 clip, where it was 1000. Here it varies between 900 to 1100 kgs, but at this level also the deflection permitted is lower than IRN 202 clip. It is 15.5 mm. These are not interchangeable and they are also theft prone. And the loosening of tow load is there, and there with the loosening of tow load there are times they also get jammed out, or rusting may also take place in these cases. This is another diagram where we can see the different types of the clips which are being used. Here it is coming this way, and then it also puts a pressure on 2 locations. Here it is putting a pressure here as well as here at these 2 locations, and this is the foot of the rail section, and here we are using the insulator at this one, and this rail section is also using a rail pad. So, this is a rail pad being shown at this level. So, this is one type of clip which is used. This is another design where what we can say is this can be termed as almost twice of the other size, and this is a type of the clip which is designed. This is IRN 202 clip, is something like this clip only. Then we have HM fastening. HM fastening is one type of fastening which can be changed from one location to the other location, and that is why the name of interchangeable fastening has been given to this. This interchangeable fastening, it is having a clip weight of 510 grams. The toe load is 1 ton, or it is 1000 kgs. It provides the dampening effect and the resistance to the lateral movement. This is another thing in this one. So, it helps out in the dampening the vibrations which are coming because of the movement of the rolling stock at the top of the rail section. At the same time, it also tries the movement of those sleepers or the rail sections in the lateral direction. So, they remain in its position. They are used with the grooved rubber pads, insulators, plastic dowels and angled guide plates. So, these are the other accessories which needs to be used when the interchangeable fastenings are used on the rail sections, but they maintain gauge. In this diagram, what we see is this HM fastening. This HM fastening is being shown here like this, though here in this diagram, because this is not a complete sort of a diagram where we can easily show the curvatures of these fastenings which are coming. This is one point from where it is starting, and this goes in this form, and there is another point here like this. So, it comes back by turning and comes at to this location. So, that this is the point where the foot of the rail section starts, and then we have the inserts. We can see the insert easily here. This is the insert provided here, this is another insert being provided here. Then there is a plate, base plate being provided at this location, and there is a liner provided here. So, this is the dash conditions, they are the liners with the grooving being used at this location. This is another diagram where the similar conditions have been shown. Here the base plate is flat in nature instead of this way, and then this is again the clip with the inserts being provided here. Then there is another type of clip which is termed as fast clip FD. This is one of the simplified systems for railway operating low or medium density operations. So far whatever clips we have seen, they are mostly in use on a medium density to a higher density route sections, whereas in those cases where the traffic is very less, we can go for smaller versions or simpler versions, and one of that is fast clip. Or they are used for the rail sections of 50 kg or below, and generally for the speeds which are lesser than 120 kilometers per hour. We can see in this diagram, this is one of the simple design of the fast clip. This goes in this form like this. So, here there is a connectivity through which it is going. So, this is the point at which it is trying to put the pressure, and that is where the toe load is getting transferred, and this is another fixture which is to be used so as to fix it in this place, along with one fixture which is used at this location like this. Then the malleable CI inserts, these are fixed directly into the concrete sleepers during manufacturing itself, and they are of two type. One is the stem type, another is gate type. In the case of a stem type, this is for normal pre-tensioned concrete sleepers, whereas the gate type is used for post-tension concrete sleepers. In the case of this stem type, the weight is 1.6 kg per piece, whereas in the case of gate type, the weight is 1.7 kg per piece. That is the difference between the two type of the inserts available to us, as we see that they are used for different type of the concrete sleepers. Pre-tension means in this case the tension is being provided before the casting of the sleeper, and once the sleeper has been casted, then it is released, and because of that releasing the stress comes and this concrete becomes a more compacted mass as well as has a higher strength. Whereas the post tension concrete sleeper is the condition where the tension in the strings through which the tension is provided is done in the later stage. This is the photograph of the CI malleable insert, and through this one it is inserted and this hole provides for the connectivity. Then we have rubber pads. These rubber pads are provided at the bottom of the rail seats so as to absorb the shocks or so as to damp or absorb the vibrations which have been induced because of the movement of the rolling stock at higher speeds at the top, or because of different other reasons, as we have seen, maybe like surface irregularities or maybe at the locations where the joints have been provided. They also resist the lateral movement of the rails because of its tendency. They will not allow the movement. They prevent abrasion of the bottom surface of the rail. This is another important thing. Because of the rubbing action between the two type of the surfaces, there are all chances that the abrasion may take place. So, as soon as we have provided the rubber pads, this chance of abrasion, that is removal of the surface material, will not be there. Then they also work as electric insulation. This is one diagram where we can see the rubber pads, and this is another diagram where we can see how they are getting fixed in location. So, here this is at this location, the pendural is to be provided at this location, similarly likewise, and these are the grooves which are provided here. We can see the grooves are like this. So, this is the shape in which it is being provided. So, grooves are in this form. So, this is the rubber pad. Then there are composite liners. These composite liners are they are provided with malleable CI or nylon components or with MS and nylon components. These are provided again so as to, with the same reason, that is we have to absorb the vibrations or the shocks which are coming. So, they are used along with the base plates as well as the these rubber pads which are taken up. Then there are different types of liners which are available. The another type of liner which is available is glass filled nylon liner. In the case of this glass filled nylon liner, these are used for track circuiting areas where the sections are subjected to severe corrosion, because if we are using these malleable type of liners, then they have the tendency to get corroded. Whereas, if these glass filled nylon liners are being used, then they are not going to be corroded here, and that is why they are a little more superior as compared to the normal type of the liners which are used. Then they are single piece, and as they are corrosion free, so they have a higher life. This is another obvious reason. Then final one is the GFC 66 liner. This GSC 66 liner, this is a rust free surface of rail with 1 in 6 slope of a rail flange it is being provided. These are 6 mm in thickness, and these are used with ERC clips. These are elastic clips, and they may damage due to rusting, or there is an uneven seating, or they may also get damaged in the yards. These are again the glass filled composite liners. They are termed as 66 number liner. So, what we have seen is that there are different types of fastenings which we can use. We have already seen is that there are fastenings which are termed as the conventional fastenings, or there are fastenings which can be termed as elastic fastenings depending on their nomenclature. Within the conventional fastenings, the fastenings are available so as to connect the rail sections with the wooden sleepers, the rail sections to the rail sections, the rail sections to the metallic sleepers like the steel trough sleepers or the CI sleepers. In the case of elastic fastenings, already we have seen there are certain requirements, and the main thing which comes is that when they are used so as to connect the rail sections with the sleepers, the toe load and the deflection is the main design criteria for those type of fastenings. Another thing is that as they are more universal in nature, therefore, they can be used at any location, whereas some of the conventional fastenings are such which can be used only one type of rail section or with some specific type of a sleeper. So, that type of restriction is not there in the case of elastic fastenings. So, with this one we stop in this lecture, and I say goodbye to you. Thank you.